Can everybody hear me?
Yep.
Mic check, mic check. All right, awesome. All right, so yeah, let's get started with today. So welcome to week 2, day 3. Yeah, today is Wednesday. Wow, started Wednesday. Week 2, day 3 of Jumpstart. We'll start class off with the review from some of last night's problem set. I have some pre-selected problems. If you guys want me to go over anything specifically, feel free to ask, and I'll be more than happy to go over it. After review, we'll jump right into lecture. And then after lecture, I will split you guys up into pairs so you guys can get started with pair programming. So yeah, that's a pretty high level overview of what we're going to be doing today. So I'll go ahead and share my screen so that we can get started. Can everybody see where it says opposite count, right in my opposite count? That takes an array. Academy open. Can you guys see that?
Yep.
Sweet, awesome, perfect. All right, so I'll start us off with the 3-step approach that we should always use whenever we encounter a coding problem. Step 1 is to read the prompt and put it in your own words. This really helps to make sure that you understand what the question is actually asking of you. Some questions are worded weirdly, some questions are just intentionally vague, and some questions you might not even know how to do, right? Like some concept in there that you don't really know. So if you run into scenarios like that and you're on your own, what you can do is look at your test cases. So test cases are your sample given inputs and your expected outputs. So this entire thing is just called a test case. So you can just look at your test cases and see if that helps in your understanding of the problem. If you're in like an interview scenario, this is where you'll have like a conversation with your interviewer, and they'll make sure that you understand what the question is actually asking of you before you get started with like your approach. Step 2 is to come up with a high-level overview of your approach to the problem. So this high-level overview doesn't need to be in code. It could be in pure English, or it could be a combination of code and English, which is just called pseudocode. Completely up to you, whatever you're most comfortable with. And then step 3 is to take your high-level overview and turn it into actual code. So seeing those 3 steps in action, this question is asking us to write a method opposite count that takes in an array of unique numbers. The method should return the number of pairs that sum to 0. Sorry, the number of pairs of elements that sum to 0. Okay, so let's take a look at some of our test cases. So on line 5, we're passed in an array with a couple of integers in it. So we're passing 2, 5, 11, -5, -2, and 7. And we're expected to return just the number 2. So the reason for that is because there are only 2 pairs that sum to 0, right? So there's 2 and -2. You add those together, you get 0. 5 and -5, you add those together and you get 0. There's nothing else that you can add together and get 0. So that's 2 pairs of elements, so we return 2. So what we'll basically do for this one is use that same pattern from last night's lecture, where we use a nested loop to get all pairs of an array. And for this case, we'll want to get all the unique pairs. And the reason for that is because remember that all pairs is going to count 2 and -2 as one pair, and -2 and 2 as another pair. But these are the same 2 elements, right? These aren't different elements, they're the same 2 elements, so they should still just count as one element. So we want all unique pairs. So once we get all the unique pairs, we'll just see if the sum of the pairs is equal to 0. If it is, we'll increment some variable that will keep count of the sum of elements that sum to 0. And then at the end, after we're done iterating through our entire array, we know that we've seen all unique pairs from our array. We should have seen every single element that, or every pair of elements that sum to 0. So we can just return that counter variable at the end. So jumping into step 3, we'll start this off by defining that variable. So we'll do count is equal to 0. This will keep track of all the elements that sum to 0. And then we want to set up our nested loop to iterate over this nums array. So we'll do nums dot each with underscore index do pipes, then put our keyword. And we'll call this outer loop block parameters num1 and idx1. And our inner loop, we want to iterate over that same array. So we'll do nums.each with underscore index, do pipes and keyword. So we'll call this inner loops block parameters num2 and idx2. So now at line 6, whenever Ruby gets to line 6 at each iteration, I'm going to have two elements, right? num1 and num2. What I want to do is see if they sum to 0. So I'll just do if num1 plus num2 is equal to 0. So this is only checking if the elements are equal to 0, right? I also need to make sure that they're unique. So I'll put and idx2 is greater than idx1. So now we have an element, two elements that sum to 0, and they're unique. So we can go ahead and increment our count variable. So we'll just do count plus equals 1. And that's all we have to do inside of our nested loop. At the end, we can just do return count. So we give that a run. And nice, you'll see we get 2 and 1. Awesome. Any questions about this one? Looks like there are no questions. There's no questions. I don't see anything in the chat. Nobody unmuting themselves. Safe to assume there's no questions. So we'll hit reset. I'll move on to the next one, which is 2D sum. All right, so this question is asking us to write a method 2D sum that takes in a 2-dimensional array and returns the sum of all elements in the array. Nice. So if you take a look at our sample test cases, on line 5, we define a 2D array with subarrays of 4, 5, and another subarray of 1, 3, 7, 1. We pass this 2D array into our method, and we're expected to return the number 21. And that's because we just take the sum of all the elements, right? So 4 plus 5 is 9, plus 1 is 10, plus 3 is 13, plus 7 is 20, plus 1 is 21. So all we have to do is just add all elements from each subarray. So we will use that same pattern from last night's lecture where we use a nested loop to iterate over a 2D array. Now, as we're iterating through the 2D array, at each element, we'll add our number to a running sum variable that we'll have. And after we're done iterating over the entire 2D array, our running sum variable should have everything added to it. So we can just return that variable at the end. So we'll just do, we'll call this sum is equal to 0. And then we want to iterate over our 2D array. So we'll do array.each, do types, put our end keyword. And then we'll call our block parameter subarray because each element inside of this 2D array is a single subarray. So we'll just call this sub_array. And now, for my inner loop, I want to iterate over each subarray, right? I don't want to iterate over the same array again. So now I want to iterate over this subarray because I want to get to the numbers. So we'll do sub_array dot each do types keyword, and then we'll call this block parameter null since each element inside each subarray is just a number. So at each element, all we want to do is just add this to the sum variable. So we'll just do sum plus equals num. And then at the end, we'll just do return sum. So we'll give that a run, and you'll see we get 21 and 15. Awesome. Any questions about this one? Looks like there are no questions. All right, looks like there's no questions. So we'll hit reset And we'll move on to our next and last one, which is pig Latin word. All right, so this question is asking us to write a method pig Latin word that takes in a word string and translates the word into pig Latin. All right, so if you look inside our editor, they do give us some additional rules. So they say pig Latin translation uses the following rules. So the first rule is for words that start with a vowel, add a yay to the end. Second rule is for words that start with a non-vowel. Let me move this onto the line. So for words that start with a non-vowel, move all letters before the first vowel to the end of the word and add a. Okay, so if you take a look at our sample inputs, on line 10, we're passed in the string apple, and we're expected to return the string apple yay. And that's because apple starts with a. A is a vowel, so we follow into this first rule. All we have to do is add yay to the end, and we just return it. So we just have this apple and then yay. Same thing for eat. Eat starts with e, which is a vowel, so we just tag on yay to the end and return that. Next up, we have banana. So banana does not start with a vowel. So what we have to do is move all letters before the first vowel to the end of the word. So we take just B, right? Because A is our first vowel. The only thing before that is B. So we take the B and we add it to the end of the word, and then we add an AY. So you'll see we get that banana, and then a B, and then AY. So we get banana bay. And then we have trash. So we have to look for the first vowel because it doesn't start with a vowel. So we need to find where the first vowel is. It's the third character. So we'll take everything that's before that and we'll add it to the end. So we'll get ASHTR, and then we'll add AY to the end. So yeah, ASHTR and then AY. So we get ashtray. So we'll handle this one case by case. So we'll start off with the first one because this one is pretty easy, right? We just have to check if it starts with a vowel, and if it does, we just tag on yay. Right, so we'll start this off by having a variable vowel set equal to A, E, I, O, and U. And now all we have to do is check if the vowels include question mark word at the index 0. So we're checking if the word starts with a vowel, and if it does, all we want to do is return word plus the string yay. Nice. Next up, the second case. So we want to move all letters before the first vowel to the end of the word. So to do that, we need to find where the first vowel is, right? So in order to do that, we must iterate over the string to see where the first vowel is going to be. So we'll do word dot each underscore char. And we do want the index over here because if I want to know where the first vowel is, where refers to position, and position is just index. So we'll do dot with underscore index. Do pipes and we'll call these block parameters char and I. So we'll do the same check as we're doing on line 9, but now instead of checking the first character, we'll check char. So we'll do if vowels dot include question mark char, put our end keyword. If the vowel, if the current character is a vowel, then we need to grab everything before the vowel. So like let's say we're given like trash. So as soon as we hit A, that's when this condition will evaluate to true, right? So when I'm at A, I want to grab T and R and add it to the end of the string, right? So I'll break this up into steps, but you could definitely do this on one line. But I'll just break it up into steps on multiple lines. So we'll do before underscore vowel is equal to word at the index of 0 up to, but not including I. So what this is going to do is grab every character from the index of 0 up to, but not including I. So the current I, like let's say we're at trash, the current I will be for A, which is 2. So it's going to grab every word from the index of 0 up to 1. So it's just going to grab T and R. And that's exactly what we want, right? We do not want to include the vowel itself, right? We only want to move everything before the first vowel to the end. So I'll just call this variable after vowel, but it should really be the vowel itself and everything after the vowel, but I'll just call it after vowel, so that it'll be easier to write. So we want this to be everything from the current index up to and including the end. So we'll just do that, -1. And now what we want to do is we want to return. So we want to flip the order that they came in. So the after vowel comes first. So the after underscore vowel plus the before underscore vowel. And then we also want to tag in an AY at the end. So we'll do AY. And we'll give that a run. Whoa. Yeah, it would kind of help if I spelled that right. There we go. So we get apple yay, ETA, banana bay, and ashtray. Nice. Any questions about this one?
So do you have to go through the character and the index, because you have to not only check each character for a vowel, but you also have to know the index to be able to rearrange the word?
Yep, perfectly. That's exactly why we need the index. Because if I have just a character, and I know that, all right, I'm iterating through the string, and I'm like, all right, my current character is a vowel, right? I kind of have no way to know where I am in the string, right? So I wouldn't know where to start my slicing, right? Like, okay, I'm at A. I know there's an A in the string, but I don't know where it is. So where do I start the split, right? So we do need the index in order for us to be able to do that.
Okay. And for the vowels dot include, is that going also through each character, or is it just it's just waiting until it hits a true statement? It's not going to go past once it finds one true statement?
Yeah, so it's not going to, so all it does is, so like, let's say we're going through like banana. So the first character, like, let's just walk through like banana. So we have B, right? So it'll come down here and it's like, all right, does vowels include the B, right? So it'll come in here and be like, all right, does B exist in this string? And it doesn't. So this will evaluate to false. So none of this code gets run and there's nothing else. So it just moves on to the next iteration, which is A. So then it's like, all right, does vowels contain the string A? And it does. A is the very first character. So this evaluates to true. So we do this, and then we return. So when we return inside of a method, whether it's in a loop, whether it's in whatever, Ruby will force exit the method and return what you tell it. It's not going to do anything else. So this A is the last iteration for this. It's not going to continue on to NA, NA. It's just not going to do that. As soon as it runs into a return keyword, that is it for that method. It just returns what you tell it.
Oh, okay, awesome. Thank you so much.
No problem. Any other questions, guys? All right, looks like there's no questions. So I'll hit reset. That was it for review. I will stop my screen share. It's 7:04. Let's take a quick 5-minute break. We'll be back at 7. Let's just make it a whole 7:10, so a 6-minute break. Let's be back at 7:10, and then we'll jump right into lecture. Alrighty, guys, let's get started with lecture. Let me share my screen. Quick mic check and share check. Can everybody hear me and see where it says week 2, day 3 hashes?
Yes.
Also perfect. Right. So the topic for today's lecture is going to be hashes. So hashes are a data structure. So as far as data structures go, we've talked about arrays, right? And what arrays did was allow us to hold multiple pieces of data and even data structures inside of it. So a structure is just used to hold multiple pieces of data. So you can basically think of a hash as the same thing, but the key difference is that hashes are used to organize data differently. So whereas arrays store data that is similar to each other, like let's say you want to have an array of foods, you can have like multiple foods in it, right? If you want to have an array of cars, you can have like multiple car types in there, stuff like that, like stuff that has like some similarity to each other. But for hashes, it's different. What you would usually use hashes for is like to store properties of something. So let me write down some notes. So hashes are a data structure that holds data in key value pairs. So each key must point to a value. There is no such thing as a key without a value, and there's no such thing as a value without a key inside of a hash. That just doesn't exist. And each key and value can be any data type. You're not restricted to certain data types when it comes to keys and values, hashes. So one important property of hashes is that each key will be unique. There's no such thing as duplicate keys in a hash. This is true across like all programming languages. And whenever you run into like a hash structure, there's going to be unique keys. So to define a hash in Ruby, we use curly braces. So to define an array, we use square brackets. To define a hash, we use curly braces. So we'll just do my underscore hash. We'll set it equal to just empty curlies. So just open curly brace and close curly brace. So this is just called an empty hash. It has no entries inside of it. There's no key value pairs inside of this hash. It's an empty data structure. So if I just print this out, let me pop open the terminal. Let's make this to the right, look nicer. And let's also toggle some word wrap so stuff doesn't get cut off. Nice. So you guys will see that we just get an empty hash. Just open curly brace, close curly brace, nothing in between. No entries inside this hash. Nice. So if we want to define a hash with entries inside of it already, I'll give you guys a blueprint for a hash. So to point a key to a value inside of a hash, we use what is called a fat arrow. It's also known as a rocket symbol. So we'll just do my underscore hash. We'll set it equal to an open curly brace, key pointing to value, and then comma, key 2 pointing to another value, close curly brace. So one thing to note over here is that each key value pair is comma separated, right? So if I wanted another key value pair over here, I would have to put a comma and then another pair. And although this is just a blueprint, we did put key and then key 2, right? So this is just to enforce that there is no such thing as duplicate keys inside of a hash. Although the values can be duplicated, right? So we put value and then value instead of like value 2. So unique keys, but there can be duplicate values. Like I was saying, hashes are generally used to store properties of something. So let's say we wanted to store properties of a laptop, for example. So we could define a hash. We'll just set equal to a variable. We'll call it laptop. So we'll just do a laptop is equal to open curly brace, And then we'll have a string of model point. Let's point it to MacBook Pro, right? Because any laptop has a model, right? So that's a property of the laptop. So just the model, we'll set it equal to a string of MacBook Pro. Let's also have a key of the color of the MacBook. So just do key of color pointing to the string silver. Let's also have 2 ports for our MacBook. So we'll just have a key of ports pointing to the number 2. And we'll have status. So if it's new, so we'll just have a key of new, set equal to the string true. And then we'll also give it some accessories. So we'll have a string of accessories and we'll point it to an array of just the mouse for now. So the only accessory this laptop has is the mouse. And then we'll close this hash off. So just like what you could do with arrays, you can put hashes on multiple lines. Ruby's not going to throw an error when you do this. If I just do p laptop and we give this a run, you'll see that we see our hash, although it's a little messy, so I'll just explain this out a little bit. And then back, so you'll see that we get that model pointing to MacBook Pro, color point to silver, port to 2, new to true, accessories to the hash, to the array of mouse. So exactly what we defined ourselves. So as you can see, there's multiple data types in here. You're not restricted to anything. So to access values inside of your laptop, just like how you would want to access values inside of like an array, right? We do want to access values inside of our hash. So instead of using an index to access values, we use the keys themselves. So you can basically think of these keys as like user-defined indices. So we use keys instead of index to access values. So like, let's say we wanted to know what the model of the laptop was. We would just do puts laptop at the key of the string model, and this will return MacBook Pro. So if you get that a run, well, oops, let me comment that out so we don't get that, and let's get some space in here. Nice. So you'll see we get MacBook Pro. To get all the other values, we just use the key that is associated with the value. So we'll just do put laptop at the key of color, and this will return silver. It puts laptop at the key of port, this will return true. True. If you put it puts laptop at the key of new, this would return true. So if we give this a run, you'll see that we get MacBook Pro, silver 2, and true. Nice. If we do puts laptop like at the key of a string of age, so age is a key that doesn't exist inside the hash, this is going to return nil because the key age doesn't exist inside of the hash. So by default, Ruby will return nil instead of throwing an error. Just like how if we would try to index into an array with an index that is too big, so if our array only has 2 elements in it, and we try to access the index of 50, Ruby's not going to throw an error. It's just going to return nil. Just like that over here, instead of returning an error saying, oh, the key of age doesn't exist inside the hash, it just returns nil by default. So let me change this to a P so we can actually see the nil being printed out. So you'll see that we get that nil printed out for that last one. Any questions so far about hashes? I feel like I've talked a lot. Any questions at all? Okay. So let's see the chat. Nobody unmuted themselves. Safe to assume there's no questions. So let's move on to some other basic operations, stuff like adding values to a hash, removing values, and changing values. So if you want to add a value to a hash, so like I said, we must in order to add an entry inside of a hash, we must have a key value pair, right? We can't just give Ruby a key and we can't just give Ruby a value and expect Ruby to add that to the hash. So if we want to add a value to a hash, we need to give it a key and we need to give it a value. So the way that goes is we call our hash, so laptop, and we'll create a key of charging and we'll set it equal to the value true. So if we do laptop, so if you print out our hash, let's clear this up. You give that a run, and let me expand this out. You'll see that at the end, we added a key of charging pointing to true. We definitely do not have that over here, right? When we defined it, our last key was accessories. But now we can see that our last key is charging, and it points to true. To delete values inside of a hash, we just use a .delete method that is available to us through Ruby. It's a built-in method. We'll just do laptop.delete, and we'll delete that key of charging. So when you delete a key, it deletes the key value pair. It doesn't just delete the key, right? Because that will leave it with the just a value. And like I said, there's no such thing as just a value inside of a hash. There's no such thing as just a key inside of a hash. So if we do put laptop after we do that delete, and we give that a run, and if we expand this back out, you'll see that this first one, we do have the charging equal to true because we added the value, and then we deleted the value, and then we printed out the hash again, and we can see that as well. Nice. If we want to change values inside of a hash, what we can do is just access the value and then mutate it. So change values inside of hash. We'll do put laptop. We'll just get a before print over here. I'll just comment these out so we don't need to see this anymore. And we'll do put laptop at the key of ports plus equals 2. So this is going to change the value to 4, and it mutates the value in the hash. So if we print out the hash again afterwards, we'll see that change take place. So if I expand this out, you'll see that in the first print, ports points to true. And then we just see this 4 being printed out because I'm printing out the actual addition happening. So we'll see that it prints out 4. So when we print out the hash again, we'll see that the value that ports points to has changed inside the hash. So if we just remember that this syntax right here, right, this plus equals 2 is just shorthand for, let me just write this down as a comment, laptop at the key of ports is equal to laptop at the key of ports plus 2, right? So what Ruby does is the first thing it will do is it'll go inside the hash and access the key of ports, right? Because in any addition, what happens is the right-hand side gets validated. So Ruby will go ahead and go laptop at the key of ports. This is just hash accessing notation, right? This is exactly this line, right? So all it does is it goes inside the hash, it grabs the value that ports points to, it grabs 2. So it will come down here and be like, it's equal to 2 plus 2, right? And that's just 4. So all it does is it does laptop at the key of ports, and we'll set it equal to 4, right? And now this notation is the same as this notation. It's adding a value to a hash, right? There's nothing different about this except for the fact that ports already exists inside of the hash, right? Over here, charging didn't exist inside the hash, but over here, ports already exists. And like I said, there is no such thing as a duplicate key inside of a hash. So when Ruby does this, when it's like, all right, I need to go inside the hash and create the key of ports, setting to the value 4, it'll go inside the hash and see that ports already exist, right? So instead of creating a new key, it'll just overwrite the old value. So it'll change this 2 to 4. And then we print out the hash, and then we'll see that change is taking place of ports 20 to 4. Any questions about any of these operations?
So you would only be able to do that if the value was a number, correct? So if it was a string, that would come out with a nil or something.
Yeah, so it wouldn't come up with a nil. It'll be like a non-implicit conversion of like number into string error. It'll be a type error
Okay.
because you can't add a string into a number or a number into a string.
Right. Okay, thank you.
Yep, no problem. So you do bring up a good point, and that is that any value that we return, we need to treat it as that data type, right? We can't treat a number as a string. We can't treat a string as a number. Likewise, if you have like an array, we can treat it like an array. So if I want to add another accessory, I can do laptop at the key of accessories and just shovel in the monitor, like if I want to add in a monitor. And this will change that array to be an array of mouse and monitor. And if I print out the hash again, so we'll do puts laptop. Let's just space it in here and we give that a run. You'll see that accessories is now pointing to an array of mouse and monitor. So whenever we access a value inside of a hash, we can treat it as that data type. And whether it's a string, whether it's an array, whether it's a number, a Boolean, another hash, no matter what it is, we can treat it as that data type. So that's why we can do a shovel over here, because this just evaluates to an array, shovel it in, it does that change, and then we can just print it out. Any questions about this? Looks like there's no questions. So let's move on to some methods that are available to us on a hash. So if we want to get the length of a hash, there is the dot length method that's available to us, just like how it is available to us on like a string or an array. So the thing about the dot length for a hash is it doesn't return the number of elements inside the hash. It returns the number of key value pairs inside of the hash. So if we do puts laptop dot length, this is going to return 5 because that is the number of key value pairs, right? So if let's go back up here, model to MacBook Pro, that's 1 key value pair, 2, 3, 4, and 5. So it's not going to go, oh, there's model MacBook Pro color silver ports to new true accessory and then an array of mouse. It's not going to count that as 10 elements. It's just going to return the number of key value pairs. So if I clear this up and we give that a run, you'll see that we get 5. Another method that's available to us is the has underscore key method, which all it does is checks if a hash contains a certain key. So if we do puts laptop that has underscore key question mark and then a string of color, this will return true. And that's because color does exist inside of the hash as a key. So it'll return true. So if we get that run, so then we get true. If we do puts laptop that has underscore key of the string price, price doesn't exist inside of our hash. So this will return false. So give that a run, you'll see that we get false. Likewise, there is a method available to us that checks if certain values exist inside of a hash. So check if certain a hash contains a certain value. We'll do puts laptop that has underscore value, and we'll pass in the string of silver. And this is going to value to true because our hash does contain silver as a value. So if we give that a run, you'll see that we get true. If we do puts laptop that has underscore value and pass in the string of webcam, so webcam does not exist inside of our hash, this is going to return false. Give that a run, you'll see we get false for that. There's also a method available to us to get all of the keys from a hash as an array. So it's just the dot keys method. So if we do p laptop dot keys, and we give that a run, you'll see that we get an array of model, color, ports, new, and accessories. So all of the keys from our hash as an array. Likewise, there is the dot values method that returns all of the values of a hash inside of an array. So we just do p laptop dot values, and if we give that a run, you'll see that we get MacBook Pro, Silver, 2, True, and then an array of just mouse. So all of our elements, or all of our values inside of a hash in this array. Any questions about any of these methods? Safe to assume there's no questions. So let's pump this hash out. We've used it quite a bit, and I'll just throw in a random hash over here. So just to show you guys that you can have any data type inside of a hash. So some common sense is you can have any data type in a hash, and we'll create a random hash. We'll just call it random underscore hash that equal to an open curly brace, and then we'll just have number 3 pointing to a string. This is the number 3. And then we'll have an array of 2 pointing to just the number 2. So now, if we do put random hash at the key of just 3, this will return this is the number 3. So the string that number 3 is pointing to. So there. You'll see that now we get this is the number 3 being printed out. So one thing to note over here is that we need to treat the key as the data type that it is when we try to access it. If it's a number, I can't try to access it as a number 3. So just like that over here, this is an array of 2. So if I want to access that key, I need to access it as the array of 2. So we'll do put random underscore hash at the key of the array of number 2 and just return 2. So these outer hashes are letting Ruby know that I'm trying to access something inside the hash. And then this inner square brackets are letting Ruby know that I'm trying to access an array of the number 2 from our hash. If I try to just do p random hash at the key of 2, this is going to return nil, right? Because just the number 2 does not exist inside of our hash. So you see that for the last one, we get nil, right? Because 2 does not exist inside of our hash as a key. So if we try to access just the key 2 without the brackets, Ruby will return nil because nothing exists in the hash for the key of 2. If we want to access that array of 2, we need to treat it like an array and access it, writing it out in array form. So yeah, just a quick little thing just to show you guys that you can have any data type. So far we did like string, number, and array. And you can also have like booleans, but that's not really useful, right? Because there's only 2 possible values of the boolean. So yeah, let's move on to hash enumerables. So just like arrays and strings, we do want to be able to iterate over our hashes sometimes. So let's define a new hash over here. We'll create a hash, we'll call it pizza. So we'll have a key of style pointing to a string of New York. We'll have a string of slices pointing to the number 8. A string of toppings pointing to an array of pepperoni and mushrooms. And we'll have key of is tasty. We'll set it to the boolean true. And we'll close this off. So to iterate over a hash, we just use the dot each enumerable. So we'll do pizza dot each do, and then we take in two block parameters. So we'll just call it key comma val. But just like array enumerables, the names over here don't really matter, right? I can call this potato and I can call this tomato, but the first block parameter will always refer to the key of the current iteration. So like, let's say we just started iterating over the hash. The first key value here is going to be style in New York. So the first block parameter is going to be the key. The second block parameter is going to be the value. Just to show you guys, we'll just print the stuff up. So we'll do put key, and then we'll do put val. And then we'll just put a couple of dashes to differentiate between different iterations. So we'll put our end keyword, and let's put this up, and we'll give this a run. Nice. So you see we get style in New York. So it puts key. The key was style, right? And that's true because that is clearly the key that we're seeing inside of our hash. And then we printed out New York, which was put val. And then we just printed out these dashes before we moved on to the next iteration. And then we just went down this and printed out each element. Just one thing to note over here is that pepperoni and mushrooms is an array. So although it appears on two lines, it's only because we're using puts, right? When we use puts on an array, it just prints that stuff on multiple lines. So if we change it to P, so we can see the data in its raw form, you'll see that it's actually just an array of pepperoni and mushrooms. There are two other enumerables available to us. There is the dot each underscore key, which will only iterate over the keys of a hash. So if we do pizza dot each underscore key, it'll take in one block parameter, we'll call it key, and then we just do puts key, and we'll just end that off. Let's clear this up. We give that a run. You'll see that we get style, slices, toppings, is tasty. So all of our keys inside of our hash. Likewise, there's the dot each underscore value that will iterate over just the values of our hash. So if you do pizza dot each underscore value, do pipes, we'll just call it val. And we'll just do p val, and we'll put our end keyword. So if you give that a run, you'll see that we get New York, 8, an array of pepperoni mushrooms, and then shrimp, which is all of the values inside of our hash. Let's any questions about any of these enumerables?
Are indices a thing with hashes?
No. So you can basically think of these keys as like user-defined indices. So you define the index and then you assign it a value. Hashes don't really use indices; they only use keys.
Okay, thank you.
Yep. Any other questions? All right. So let's move on to our next little topic, which is going to be assigning default values to a cache. So we'll see why this is useful in certain cases. So assigning default value to a cache. So like I showed you guys before, keys that don't exist in a hash have a default value of nil. Right? So if I just do counter is equal to an empty hash, and then I try to do p counter at the string of j, this is going to return nil, right? Because this is an empty hash, it doesn't contain any key value pairs. So when I try to access something that doesn't exist inside the hash, it'll automatically return nil. I'm able to change this default value by initializing my hash in a different way. So we'll just comment this out, and we'll do counter is equal to hash, the word hash dot new, and then we'll pass in 0. So this is going to give this hash the default value of 0 instead of nil. So now when I try to do p counter at the string of j, and we give that a run, you'll see that now I get a 0 instead of nil, right? So this is the same 2 lines of code. The only difference was the way I initialized the hash, right? Using this way, it returned nil. Using this way, since I passed in a 0, it returned 0. That doesn't mean that the key of j exists inside of the hash automatically and it's pointing to a value of 0. All it's really doing is saying, hey, j doesn't exist. You're trying to access something that doesn't exist. Here, take 0 since you wanted 0. Since you told me you wanted 0 for something that doesn't exist, take 0. If I just do p counter after that, we'll see that it's still just an empty hash, right? Nothing exists inside of the hash. So why is this useful? So we can use this little pattern over here. We'll just keep this over here, counted in, to like count the frequencies of characters inside of a string. So this one quick little thing, you can put any data type to the hash.new method. You're not restricted to just numbers or something when passing any data type. So let's say we have a string of Jumpstart, set equal to the variable str, and we want to count the frequencies of these characters. So actually, this wouldn't really be an interesting string. The only repeating characters there are like these two T's. Repeating character. We'll just call it Mississippi. There's a lot of repeating characters. Mississippi. Hope I spelled that right. So we'll do str.each underscore char do pipes char. So we're iterating over the string. We'll call out block parameter char. And now to count the frequencies of these characters, all I need to do is add each character to my hash as a key, and its value will be kind of like an incrementer. So it'll keep track of how many times it's seen the character. So every single time I run into the character, I'll increment it. So I'll just do a plus equals 1. So we'll do counter at the key of char plus equals 1, and we'll put our end keyword. And then if we do a p counter, clear this up, and we give that a run, you'll see that m points to 1, I points to 4, s points to 4, and p points to 2. So if I did this using this way of initializing the hash instead of this one, when I give this a run, we'll see right away that Ruby just says undefined method plus for nil class. So I tried to access something that didn't exist inside of the hash. So Ruby just threw that error because it was like, hey, you just have to add 1 to nil. Since you can see that I'm adding 1 to whatever I grab from the hash. And if something doesn't exist, it has a default value of nil. So right off the bat, it's like, this is not going to fly. Take this error and fix it. So that's why this pattern is sometimes useful for cases like this. Any questions about this? How it works or anything? Okay, looks like there's no questions. So I just have one more method to get through. So that is the .sort underscore by. So if we do p counter .sort underscore by, and we'll put curly braces, and then pipes k comma v, and we just pass in v, it's going to sort all of these entries of our hash by the values. So if we give this a run, you'll see that we get M1, P2, I4, S4. So it's 1, 2, 4, 4. So it's ascending in for the values, and that's how it's sorted. We can also like reverse that. So if we just do p counter dot sort underscore pi, just do open curly brace k comma v and then negative v. This is going to reverse the order that is happening in. So if we give that a run, you'll see then now we get 4, 4, 2, and then 1. We can also sort them by the keys. So if you do p counter dot sort underscore by, and then open curly brace types k comma v, we'll pass in k. And if we give this a run, you'll see that we get IMPS. That actually kind of spells it. I don't know why I said that, but yeah. So you can see that now it's sorted alphabetically in ascending order. So just a cool little thing that may or may not be useful. Any questions about this or well anything from today's lecture? This is the last thing I had for lecture, so if you guys have like any questions at all, please feel free to ask. Any questions? All right. See anybody unmuting themselves or any activity in the chat. So there's no questions, so I will stop my screen share. I will send you guys these notes in your guys' Slack channel, so you guys will have access to them as you guys are working through tonight's problem set. But before I do that, let me split you guys up into breakout rooms so you guys can get started with pair programming. So today, all you guys are going to work on are the problems under week 2, day 3. If you guys have any questions at any point in time, shoot me a message on Slack. I will go ahead and join your guys' breakout room and then help you guys out. And once you guys are done, feel free to leave. I have nothing else for you guys today. So yeah, I'm about to open up all the rooms. Go ahead and join them and have fun pair programming, guys.
Thank you.
No problem.